So now we can look at factoring cubes. So this would be the sum of two cubes and the difference of two cubes. So we talk very similar to the difference of two squares that we've seen before. So a cubed plus b cubed is going to split to follow this template. A plus b, a squared minus ab plus b squared. The difference of cubes, a cubed minus b cubed, is going to follow a minus b, a squared plus ab plus b squared. We notice some patterns that start to develop. If we see that this has the same sign as the positive that it started with, so does in the difference. The negative and positive here are the opposite signs. Then the last term is positive in both of them, so I'm going to write always positive. So what we start to see from that is same, opposite, always positive. There's an acronym there. We can say SOAP that helps us remember the signs. So depending whether it's positive or negative, it will help us translate it over to the template that we have. So from there, we just need to remember a, b, a squared, ab, b squared. So let's work through a few examples of this. So a to the third plus 8. Now 8 is 2 to the third. So I'm going to think that b in this case is 2. And I'm going to use the same template that I have up here. So the template followed. It was a plus b, a squared minus ab plus b squared. I'm just going to fill in what I got. So first one is a plus 2. Then we go a squared minus ab, so that's 2 times a, plus b squared, which is 2 squared, 4. And there's my factored version of a cubed plus 8. It's a plus 2 times a squared minus 2a plus 4. Now this will not factor for what we have. We're just going to leave it as a trinomial. This could, in some circumstances, we won't see many of those, but it could possibly be a difference of squares if we had higher exponents to start with. But in most cases, this would be our factored form. So let's look over at the negative side. So now it went same sign, negative, positive on the opposite, and then always positive. So this one, we just have that b is 1 because 1 to the third is 1. So we're going to go a minus b, so a minus 1, a squared plus ab, so that's 1 and a, just a, plus 1 squared, or 1. So there's our factors. Now, we come down to our next set. 2x cubed plus 128 is not perfect squares, but we need to be ready to see GCFs, greatest common factors. So 64 is 4 to the third. So we're going to say that b equals 4. So we have 2 on the outside, and let's fill it in. So we're going to go, it's same sign, opposite, always positive. It was a, b, a squared, ab, b squared. So x is our first term, that's a. So we're going to put there and here. Bring down the plus, the minus, and the plus. Now b was 4. So it becomes x plus 4. Negative ab is just 4 times x, 4x. And then b squared, since it's 4, is going to be 16. So it's 2 times x plus 4 times x minus 2 minus 4x plus 16. Next, 343x cubed minus 64. 343 is the cube of 7. So I'm going to say that a is now 7x. b, I'm going to say, is 4. So to fill in the template that we have, if we look at the parts, we have a minus b, then it's a squared plus ab plus b squared. So first is a, so that's 7x minus 4. Then we have a squared, so that's 7x squared is 49x squared, plus 7x and 4 is 28x, then b squared is 16. So there is our factors of the perfect cube. Okay, moving down. 27n to the third minus 1. 27n to the third, we're going to say that a is 3n, and then b is 1. So it's going to be 3n minus 1, same sign on the minus. Then it's 3n squared, which is 9n squared, opposite sign. 3n times 1 is 3n, and then 1 squared, the always positive 1 at the end. Well, what if we had 15w to the third minus 15? Now, 5 to the third is not 15, so don't think that's a perfect cube. This is a GCF. We're going to take 15 out, factor it out. We have w to the third minus 1, with a being w and b being 1. So it's more of a recognize the GCF, and then that you have the cubes to simplify. So we're going to go same sign, opposite, always positive. It would be w minus 1, w squared, 1w, 1 squared. Now we come down to 2k to the fourth minus 16k, and at first look, then it's suddenly looking at maybe is it rule with dealing with fourth power. Not what we're doing here. We need to look for a GCF. They both have a 2k in common, so that becomes k cubed minus 8. Now that means 8 is 2 to the third, so we're going to go 2k, that's our GCF, and then to use our pattern, we're going to go same sign, opposite sign, always positive. K minus 2, k squared, 2 times k, and then 2 squared is 4. 64 plus m to the third. 64 is 4 to the third. We have plus, so that's same sign, opposite sign, always positive. We're going to go 4 plus m. 4 squared, then 16, and then we're going to do 4 times m, and then m squared as our last one. Now, this is the same thing as writing m cubed plus 64, so I could rearrange this to be m squared minus 4m plus 16, and I could switch this also to be m plus 4, and they are equivalent. We just usually write the order they gave us, but that would also be correct. It's just kind of a switched version. Now, what if it's suddenly a cubed b cubed? We have to remember that this is the same as saying ab to the third, which means that ab is that first unit that we want. So our signs, we go same sign, opposite, always positive. It's the first unit squared, or no, I'm sorry, it's first unit, ab, minus c. Then it's the first unit squared, a squared, b squared. Then we multiply the two, a, b, c, and then the last term squared, c squared. 27j to the third is the same as saying 3j cubed. 125k to the third is the same as saying 5k to the third. So we're going to go same sign, opposite sign, always positive. 3j minus 5k. Square it, 9j squared. Multiply them together, 15jk. And then the last term squared, 25k squared. A to the sixth minus 8. Now, a to the sixth is a squared to the third. So the a squared is going to be the unit we work with, and 8 is 2 to the third. So we start with a squared, that is same sign, better fill in my signs there, same sign, opposite, always positive. So a squared minus 2. This squared, a squared squared, is a to the fourth. Multiply the two, 2a squared. And then the last term squared, 2 squared, is 4. Now, this would be the one that would factor a little bit more if it was difference of squares. So instead of 2 here, if it was a 4, a 9, a 16, this would factor down a little bit more, but this will not. That's where that factoring the additional step might come in. Okay, last one we're looking at, we have a rectangular prism where the volume is 2x to the third plus 54. inches cubed. Now I could factor out a 2 here, and I get x cubed plus 27, which kind of leans itself to what we've been looking at. We also know that the volume of a prism is the height times the base area. Now I already know that the height is 2, so what we're really looking at here is the base area is x to the third plus 27. So when it asks for what is the possible length and width, what we have to do is we have to factor this term to find what the factors are, which could be length or width. It doesn't matter which one's which, we just need to show that we can factor it. This is a sum of cubes, which we've been looking at. This is 3 to the third. So we write out our factors. We go same sign, opposite sign, always positive. It'll be x plus 3, x squared, 3x, and then 3 squared is 9. So these two factors, again, doesn't matter which one's which, could be the possible dimensions for length and width.